Okay, this is College Algebra Dual Credit, Unit 1, Notes 2, Multiply and Dividing Fractions. So first we're going to go over some definitions. So we have improper fraction. An improper fraction is a fraction where the numerator is larger than the denominator. So in our example, 9 over 2, 9 is greater than 2, and it's on the numerator, which makes it an improper fraction. Then we have a mixed number. A mixed number is a whole number attached to a fraction. So for example, 2 1/3. Product is the answer to a multiplication problem, and the answer to a division problem is a quotient. And then lastly, a reciprocal. The definition of that is simply to flip the fraction. So if I start off with 2 over 3, the reciprocal of that would be the opposite. So the numerator goes to the denominator and vice versa, and it becomes 3 over 2. We flip the fraction. So looking at rule number 1 is just multiplying fractions. So notice I have the formula here. I have some fraction, a over b, times another fraction, c over d. Well, when multiplying fractions, I simply multiply the numerators together, so a times c, and then the denominators together, b times d. So looking at an example here, I have 2/3 times 4/5. So 2 times 4 is 8. 3 times 5 is 15. So my answer is 8 over 15. Okay, same with number 2. I have 1/2 times 3/5. Multiply the numerators and I get 3. Multiply the denominators and I get 10. So my answer is 3/10. Rule number 2 is, well, what happens if we have a whole number that is being multiplied by a fraction? Anytime you have that whole number, we're going to take that whole number and turn it into a fraction by putting that value over 1. So now I have 5 over 1 times 2 over 3. And then we're going to do the same exact thing. So numerators get multiplied together. 5 times 2 is 10. Denominators get multiplied together. 1 times 3 is 3. Okay. Same with number 4. We have 3 times 2/5. I'm going to change the 3 into a fraction by putting it over 1, and then I'm going to multiply across. 3 times 2 is 6. 1 times 5 is 5. So my answer is 6 over 5. Okay. Rule number 3 is dividing fractions. So you may have learned about keep, change, flip. So keep, remember, means to keep the first fraction the same. Change means to change the division to a multiplication. And flip means we flip the second fraction. However, after this, I'm no longer going to say flip. We are going to use the word reciprocal. So if I ask you to take the reciprocal, that simply means to flip the fraction. So let's look at an example. So we have 3 over 4 divided by 5 over 2. So I'm going to keep the first fraction, 3 over 4. I'm going to change the symbol to multiplication, and I'm going to take the reciprocal of 5 over 2, which is 2 over 5. Once I go through that process, then I'm going to multiply the numerators, multiply the denominators, just like normal. So I have 3 times 2, which is 6, 4 times 5, which is 20. And then notice that 6 and 20 can simplify. And they can simplify by dividing both of them by the exact same number. So for example, I can divide 6 by 2 and 20 by 2. And when I do that, I get 3 over 10. So 3 over 10 is my answer because it's the most simplified fraction. Okay. Looking at number 6, I have 5 over 6 divided by 1 over 3. So I'm going to keep my first fraction, change to multiplication, and then write the reciprocal, which is 3 over 1. Then I'm going to multiply across, and I get 15 over 6. Again, notice how I can simplify this because both the numerator and the denominator are divisible by 3. So if I divide 15 by 3, I get 5, and 6 by 3, I get 2. So my simplified fraction is 5 over 2. Okay. Rule number 4 Mixed number. So what happens if we have a mixed number? So remember, a mixed number is a whole number attached to a fraction. So if we look at number 7, we have 2 1/2 times 3/4. So first, I need to change this into an improper fraction, and I do that by starting at the whole number, taking that whole number and multiplying it by the denominator, and then whatever I get there, I'm going to add it to the numerator. So I have 2 times 2, which is 4, 4 plus 1, which is 5, and then I keep the same denominator. So this becomes 5/2. Okay. Then I just rewrite everything else, so I bring over my 3 times 4, and since I'm multiplying, I just simply multiply across, and I get 15/8. Notice this is my answer because I'm not able to divide both the numerator and the denominator by the same number. Okay, that's the most important part here, the same number. Okay, number 8, we have 1/7 divided by 2 2/3. So first I have to change this into an improper fraction. So I'm going to multiply 2 times 3, which is 6, and I'm going to add 6 plus 2, which is 8. So really, I have 1/7 divided by 8/3. Okay, now I go about the same process for dividing fractions, and I keep the first fraction, change to multiplication, and then take the reciprocal of 8/3, which is 3/8, and then I multiply across, and I get 3/56. Okay. Last problem here is an application problem. So it says a bag has 4.5 pounds of candy. If each smaller bag can hold 3/4 of a pound, how many bags can we fill? And so when we're doing some of these problems, I notice some of you are taking, for example, the 3/4, and you are adding them a bunch of times until you get to 4.5. Okay, that is one way to do it. However, that process can take time. So the most efficient way is to divide these two fractions. So we have 4.5 divided by 3/4. So how many 3/4 pounds of candy can we get out of 4.5 pounds of candy? And so in order to do this, we first need to change our mixed number into an improper fraction. So we have 4 times 2, which is 8, plus 1, which is 9. So I have 9/2 divided by 3/4. Then I keep my first fraction, change my sign, and do the reciprocal of the second fraction. So now I have 9/2 times 4/3. Multiply across, I have 36/6, which is just 6. Okay. However, I can't just write 6 and then write bags. Okay, that's another mistake I'm seeing a lot. Okay, that would not be a full credit answer. In order to get full credit, you would have to write a statement. So we would say, we can fill 6 smaller bags. And this statement here would be our answer.